Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is the coordinate geometry. What you are going to learn today is how to find the coordinate of a midpoint. So let's begin. After completing the very lesson today, my dear student, will be able to find the coordinate of the midpoint of a line segment. This is what I hope you'll be able to do after completing the very lesson today. So as usual in your favorite segment of the lesson, that is Maths Fun, today as I promise you that I'm going to give you interesting properties of Pascal triangle. I'll start with the very first one. Today I'll give you one of the interesting properties of Pascal triangle, and that will be done after completing my lesson today, so don't go away. So to begin the lesson, let us first define what is a midpoint of a line segment. A point which divides a line segment into two equal halves is called a midpoint. So that very point that divides your line segment into exactly two equal halves, that point is called a midpoint. So let's learn how to find the coordinate of that midpoint. So if M is the midpoint of a line segment AB, for example, and that line segment AB has endpoints at A with coordinate x1, y1, and the other endpoint B with the coordinate x2, y2 are displayed in this Cartesian plane. Look at the point A with the coordinate x1, y1, and look at the point B with the coordinate x2, y2. And this is the point M that divides this line AB exactly into two equal halves. That if we are to find the coordinate of the midpoint, that is what will be the value of x and what will be the value of y at exactly this point. And what we need to do, we simply use this very simple formula. The coordinate of the point M, where M is the midpoint, is nothing but the x coordinate of that M is the something as x1 plus x2 divided by 2, where x1 is the x coordinate at the point E, look at it, and the x2 is the x coordinate at the point B. So if we are to find the x coordinate of the 2 points, that is of the 2 endpoints, and sum them and find the average, that is divided by 2, it will give you the x coordinate at the midpoint. Similarly, the y coordinate will now be nothing but the average of the y coordinate at the 2 endpoints. That is, you now find the sum of y2 and y1 and divide the result by 2. This is the simple formula we used to find the coordinate of the midpoint. We are going to take an example just now and see how we can make use of this formula to find the coordinate of the midpoint. So let us move. Example number 1, it says find the midpoint of this line AB. But the line AB has endpoints at A with coordinate -3, 4, and the another endpoint at B with the coordinate 5, -3. Solution to this very problem, what you just do, you write down the formula for finding coordinate of the midpoint. Remember, the coordinate of the midpoint, it says M. The x coordinate is nothing but x1 plus x2 divided by 2. And the y coordinate is nothing but y1 plus y2 divided by 2. So what do you need to do? These two endpoints, you now mark one of them to be having coordinate x1, y1, and the other one to be having coordinate x2, y2. Let me do that. So if I now take this -3 to be x1 and this 5 to be my x2, that is, point A is the one with the coordinate x1, y1, and the point B is the one with the coordinate x2, y2. So I'm going to substitute my x1 here and my x2 in this very formula to begin finding the x coordinate of the midpoint M. So let me do that. So I'm going to have M open bracket. I'm starting with the x coordinate. There I have -3 plus 5 over 2. -3 is the value of x1. Look at it here. I'm just replacing in this very formula. This is my x1 is now -3. And my x2, which is 5 here, look at it. So divided by 2. So I'll continue. So I'll now move to the y coordinate. The y coordinate of that midpoint. So I'll now later this 4 to be my y1 and this -3 to be my y2. So substituted in this formula, that is y1 plus y2 divided by 2, I'm going to have 4 plus open bracket -3. minus 3 is you have y2, look at it here, divided by 2. So what remains is to simplify this brackets. So minus 3 plus 5 will give result positive 2, and that positive 2 divided by 2 will give you 1. That is the x-coordinate of the midpoint. Similarly, 4 plus minus 3 plus minus is minus. So in the area you have 4 minus 3, which gives you 1. And you have 1 over 2. So the m coordinate will now be nothing but 1 comma 1 over 2. What is the x coordinate, which is the result of minus 3 plus 5 divided by 2, while the y coordinate is 1 over 2, which is the result of this 4 plus minus 3 divided by 2. So this is the coordinate of the midpoint of this line segment. Let's just take one more example. Example number 2, it says the midpoint of line ST is the point N, and that point N has coordinate 5 comma minus 3. And one of the endpoint of that line ST, which is the point S, is at the coordinate minus 1 comma 7. So the question asked here is to find the coordinate of the other endpoint T. Solution to this very problem. So in this example, we have the coordinate of the midpoint, and that midpoint is lettered N. It's lettered N, and that line segment is the line ST. And one endpoint of that line ST is the point S. The coordinate is given. What we are asked here is to find the coordinate of the other endpoint. So let me do that. So I'll write my formula, finding coordinate of the midpoint. The coordinate of the midpoint, which is x1 plus x2 over 2. This gives the x coordinate. y1 plus y2 all over 2. This gives the y coordinate, as the coordinate of that midpoint is given. So I'll say equals to 5 comma minus 3. The coordinate of that midpoint is given. Look at it here. It says it's the point N with the coordinate 5 comma minus 3. So that's why I'm equating it like this. So I continue. So this 5 is now the x coordinate of the midpoint, and the minus 3 is the y coordinate of the midpoint. So I'm going to have x1 plus x2 all over 2 to be equals to this 5. Like I have said, this is the x coordinate of the midpoint, and this y1 plus y2 divided by 2 will be the same thing as this minus 3, the y coordinate of the midpoint. So I'm going to substitute this x1 by minus 1 and y1 by 7 and solve this equation. So starting with this equation, so I'll get my x2. In this equation also, I'm going to get y2. So let me start with the very first equation. So substituted x1 by minus 1, I'm going to have minus 1 plus x2 all over 2 equals to 5. There cross multiply, I'm going to have minus 1 plus x2 equals to 10. So taken like terms, by meaning minus 1, move to the right hand side, I'm going to have x2 to be equals to 11. So I'm going to solve this equation. So I'm substituting this y1 by this number 7. So I'm going to have a 7 plus y2 all over 2 equals to minus 3. There you cross multiply. I'm going to have 7 plus y2 equals to minus 6. And collecting like terms that there, 7 shifted to the right hand side will leave you with y2 equals to minus 13. Minus 13 is minus 6 minus 7. 7 shifted to the right becomes negative. So I have y2 equals to minus 13. So this is the x coordinate of the point T, and this is the y coordinate of the point T. So there we now write the coordinate of that point T, that is the other end point of the line ST, to be equals to, starting with the x coordinate, which is 11, and the y coordinate, which is minus 13. So this is what we do to find the coordinate of the midpoint of the line segment. And with these few examples, I will stop in this very lesson. I hope you can be able to find the coordinate of the midpoint of any line segment. Thank you for your attention, and let me just move to the last segment to Mercy Sefan. So like I have said initially while introducing Pascal triangle, this is has a lot of interesting properties. This is your Pascal triangle. The property we're going to see here is the very first property, and that property is a sum of all the numbers in each row is a power of 2. I have first row, second row, third row, like that. So what this property is saying, if you are to add all the numbers in each row, the result you are going to have is now a power of 2. Let's start with the first row. The first row contains only this number 1, and this one is nothing but 2 raised to the power of 0. Remember the indices, anything raised to the power of 0, the result is 1. Let me move to the second row. So I have two numbers, 1 and 1. Addition of those two numbers gives me 2, and the 2 is nothing but 2 to the power of 1. Let me move to the third row. I have three numbers, 1, 2, and 1. Addition of those three numbers will give you 4, and the 4 is nothing but 2 to the power of 2. This is amazing. Let me just move and test to see whether the fourth row is also the same. So the fourth row, I have 4 numbers there, 1, 3, 3, and this one. Addition of those numbers gives me 8, and 8 is nothing but 2 to the power of 3. This is interesting. So I move to the fifth row. Fifth row have 5 numbers, 1 plus 4, 5 plus 6, 11 plus 4. That gives me 15 plus what is 16, and 16 is nothing but 2 to the power of 4. This is interesting. So all the numbers according to this very property says if you add all the numbers in each row, what you have is a power of 2. So addition of the other one is 32, and 32 is 2 to the power of 5. The next row is 64. 64 is 2 to the power of 6. Next row is 128. If you add, you see exactly this what is happening. So this is interesting. So addition of all the numbers in each row in your Pascal triangle, when you add them, the result is nothing but a power of 2. This is interesting. We will have another property of this Pascal triangle in our next lesson. Thank you for your attention.